Hello, my name is Jake Muhlstein, and this is my presentation for the final 4-bit microprocessor. I'm just going to go ahead and enable the tick so you can see the functionality of it. So on the left-hand side, we have our clock being fed into our synchronous counter that just counts up. That is attached to our PROM. The PROM is the programmable read-only memory, and that's where we're housing the instructions for this 4-bit microprocessor. The PROM is the first 4 bits of the PROM go and they're fed into the instruction decoder up top, and then we have the second 4 bits, if it's necessary, to be transferred over to the register. So you can see that it ran all the way through. It's going to start over, so let's stop that. Let's talk about it a little bit more. So I've added these two outputs just so we could see the register file for register 0 and register 1, so that while it's running you can see those different values. What we were asked to do with this program is to first output hello dash and then brother N for Brother Nelson, or BN for Brother Nelson, and then do some arithmetic. And using the ALU, we are able to add 3 plus 4 equals 7, 3 times 3 equals 9, 4 minus 3 using the ALU to get 1, and then 4 minus 3 equals 1 using the subtraction hardware. So just to show a little bit of the subcircuits, is here is our register file. It's 2-bit or a 2-word 4-bit registers, and if we go down more into it, we have our decoder, which determines the write enabled and the address depending upon the clock input. And then if you look further down, we can see that we have our single register with the muxes and the flip-flops. So coming back out, the 2-word 4-bit register has 2 outputs. We have the output of the ASCII output and also being fed into the ALU. So here's the ALU. It's the same one that we used in the lab. I didn't change very much, except I did add down below the accumulator, and that is just a register file or just a single register to hold the 4-bit answer for the logic that's being passed in. And so we were asked to do a couple of different equations, 3 plus 4, and so we'd add those into the register and then use the add functionality, and then it would output 7. We'd save that into the register 0, and then we'd go ahead and output to register to the number 3, because the ASCII value for 7 is, well, any number is the number preceded by a 3. So that was how I was able to output the values for the different equations. For 3 times 3, what we did is we just added 3 together 3 times. And then to do the 4 minus 3 without the hardware, the software version, a little bit more complicated. Had to just using add functions and storing the different values in the register. We had 0 plus 3, and then we stored 3 in register 0, added to 3, gives you 6, which I put into register 0, added it to the 3 that was still in register 1 to give me 9. 9 into register 1, added to 3, gave me 12. 12 into register 1, with 9 still in register 0, gave me, after everything's reduced, 5. 5 put in register 0, added to the 12 in register 1, gave me 1. Put 1 in register 0, added it to 12, that gave me 13, which 13 is the 2's complement of negative 3, and we're able to take that, add it to 4, which gave me 1. Then I put that in register 0 with the 3 in register 1, which again we needed to precede the number, our answer, with a 3 to go ahead and output the ASCII value. With the subtractor hardware, went ahead and used the book and found the equation that we would need in order to create a 1-bit subtractor, and then we're able to make the subtractor hardware by adding 4 of those together. I put them into an AND gate that was being edited by a input bit that would turn it on and off, basically making it enabled or not. And then we added it to the ALU right here. And then we're able to use the equation and the output using, depending upon what was stored in the accumulator or the subtractor hardware, what the output would be. So if we wanted to output anything from the subtractor hardware, I had to go ahead and clear out the accumulator by feeding zeros into register 0 and register 1. And then I could go ahead and use the subtractor hardware to output the answer to 4 minus 3 and save it to a register and then output it to the file. Again, this is my project, and thank you very much. Sorry, it's over 2 minutes.